Thanks for coming out. I know it's the end of the day, so I appreciate you all being here. My name is Jed Sundwall. I'm here, I'm the Open Data Technical Business Development Manager at AWS. And so I'm on our Open Data team, which is part of our public sector team. And what we do is we help our government customers, or our public sector customers, so whether they're government organizations or research institutions, if they have data that they want to open up, we help them understand how they can use AWS products to do that, or work with our partners to do that. And so, are my slides up? So, I'm going to talk about open data innovation, and how opening up data on AWS can help drive innovation. So I'm going to talk firstly about just sort of what is open data, and how we think about it and why it matters to our business. And then I'm going to talk about Landsat on AWS, which is our newest public data set. So we have a program called the Public Data Sets Program, where we will store data for anyone to use for any purpose that they want on AWS. And we'll be talking about Landsat, which is our newest data set that we've made available that way. And then I'll invite Frank Warmerdam from PlanetLabs on stage, and he's going to talk about how PlanetLabs uses open data to build their products and why they rely on it, and the benefits of having open data available to them on AWS. And then finally, I'll just wrap up with a few words on what you can expect from us in terms of the Open Data on AWS program and what we're doing moving forward with new data sets. So what is open data? So we do actually get this question a lot. People are like, oh, open data, that sounds interesting. What is that? We use a very, very basic term or basic definition of open data, which is that it's data that anyone can use for free for any purpose. There are no license restrictions on it, and it's available for them to do whatever they want with. And so the government produces a lot of open data that they actually encourage people to use. A very obvious example of this is weather data. And open data matters to AWS because it matters to our customers. We have customers like ESRI, like the Climate Corporation, and the Weather Company, that their products wouldn't exist without open data. And so to the extent that we can make it easier for them to work with open data on AWS, that serves them, that helps them build better products for their customers, and so it matters to us. Now, one of the beautiful things about AWS is that we have a full toolkit that allows you to work with data at any scale. So what I have right here are just brief overviews of just 3 of our products, S3, EMR, and DynamoDB, that allow you to work with data at any scale. S3 is sort of one of our core products. It's our object storage. You can store any kind of data in there, up to effectively infinite size, pretty much as you want, and you can share it with anyone. So any object or any data that you put in S3, you can make as widely available to anyone on the entire internet, or you can narrow it down and share it only with stakeholders. But we provide a lot of granular control on how that data is made available. EMR it's Elastic MapReduce, so it takes out a lot of the hassle of using the Hadoop big data analysis framework, and so you can do that on AWS, and it pairs very nicely with S3. And then DynamoDB is a NoSQL managed database service. So that's one of our managed database services that you can use. So when it comes time for you to take some open data and build it into an application for people to use, DynamoDB is one example of a database that you could use to do that, extremely quickly and effectively infinitely at infinite scale. And so the value of open data on AWS is it's very, very basic, and this is sort of a simplistic explanation of this. But when you put data on S3, so in this slide we've got an S3 bucket, it is close to our computers. It is close to our computing resources, and that's actually tremendously valuable, because when you have data, data on its own is only so valuable. It becomes valuable along with algorithms and computing. And so if you have the data available in an environment, and it's readily available in an environment where you can spin up our on-demand compute resources, you can perform analysis on that data very, very quickly with no upfront cost and capital expenditure, which reduces the time to science. It reduces the time required to build new products or build data products for your customers. So you can take the data out of S3, put it into a database. You can process it with an EC2 server, or use Hadoop to do that, and then put it into a database, whatever you want. Now, just to give you an example of the scale of working with data on AWS and open data on AWS is, the weather company has a great example. Obviously, the weather company, millions of people use their products every day. They analyze more than 4 gigabytes of weather data per second from over 800 different sources. So yeah, obviously, some of those sources are proprietary. That is licensed data, but a lot of the sources of data that they get come from the government, from radar data and satellite data and things like that. So this is an example of the scale. Not everybody operates at the scale, but it's certainly possible to do tremendous things at tremendous scale on AWS. And another explanation of how open data works and where the value of open data comes from, I think can be summed up in this graph. So this is a graph that's heavily inspired by Socrata. Socrata, they use something like this in a lot of their presentations. They call it an open data Odyssey. And it's an attempt to explain, how does a data point go from being, a datum, a figure, a fact, or something like that, and turn into something valuable in the economy. And so we have 2 axes here. So on the y-axis, I have what I call sense making. Sense making is just innovations in how you help people understand what the data is actually telling you. What are the insights? And so sense making can be a visualization, an interactive chart, an application. It can be like a simple story. Storytelling is sense making. So as you have innovations in sense making, you go up the y-axis. And then as you proceed along the x-axis, we have data enrichment. And so that's data cleanup, mashing up data with other data sources and combining it with other data sources, and otherwise analyzing the data to find insights from it. And as you progress along these axes, what we're getting at, and I have up there in the top right, is a lower cost of knowledge. This is one of the real value of open data and having data available to people, is that people can know very basic facts about their world at much, much lower cost and much more quickly. The value of knowledge increases dramatically with reduced time. So if you can know a fact that's relevant for your business, or if your customers can know a fact that's relevant to their lives sooner, that enables them to make a better decision more quickly, which is tremendously valuable. And so it's that kind of efficiency that leads to quicker routing, for shipping materials and things like that, lower cost of developing products. It helps people know, how much should I irrigate here, or what kind of crops should I plant here. It helps parents understand, which schools they want to send their kids to, or helps people decide what house or what neighborhood they want to move into. And the way they make those decisions is based on using applications and using software, increasingly. You use an app, or it's just built into your iPhone. You have the ability to know before you leave the house, should I wear a jacket? Or before you go on a trip, what should you pack for that trip? It's very, very hard to sort of place a monetary value on that kind of thing, but you can just imagine what it'd be like to not have that data available to you. We take that for granted. And that stuff comes from open data. And the ability of people to build more applications and more products like that is dependent on more open data being available. So that's what we're trying to do. Now there's another component to this graph, though, which is data creation. And the reason I show that, and I sort of add this sort of like what happens before you have data at rest so that it can turn into these things, is to demonstrate how AWS fits onto this graph. And the fact is that we have products that exist appropriately everywhere on the graph. Now, I tried to make a nice, pretty graph. The fact is that I have another version of this graph that I won't show. It's just super messy, because all of our products fit in various different ways all over the place. So, you might use S3 down in the lower left, that's data at rest, but you'll also use it later on once you've enriched products. You create derived data products, and you'll store that in S3. But you get the general idea. We have products like Kinesis and EC2 that can allow you to collect and process and analyze data, store it, throw into S3, and then make it available. And once it's in S3, you can use all these other products to analyze it and store it and make it available through different applications. And so, so what does this look like? I can just give a couple examples of these applications. I mean, one thing is like, I mentioned already the weather company. You can think of the Weather Channel as an application of open data. A lot of people don't think about it that way, like you tune into a TV station, but it really is an application of the data. Same thing, when you read a data-based story in a newspaper. But as in these days of apps, and we always talk about there's an app for that and this and that, MoveIt is a good example. It's actually a really great example of an application that demonstrates what I showed off in this slide, where you have a mobile device. It's an application that uses data, open data from a municipality, to help people understand how they can navigate around their city, how they can get around through public transit. But it does something very interesting as well, is that when users use MoveIt, they're also producing data. They're acting as citizen sensors, if you will, and they send data back that the government's able to use to improve their service delivery, so they can get a better understanding of their transit system and make improvements. So it creates a really nice virtuous cycle based on the data, and they do this all on AWS. And then another really good public sector example is in Singapore. The Singapore government has a thing called OneMap, which is powered by AWS, and it's a consolidated centralized mapping infrastructure for the entire government of Singapore, but also for the commercial sector in Singapore. And it reduced costs dramatically when they implemented it by 60%, because they were actually able to pool a lot of resources into one place. And OneMap powers more than 100 applications, not only from the government, but also from the commercial sector. And it's hit over 150 million times every month. And so it's a great example of what happens when data is available in the cloud that, like I said before, it's close to computing resources. So if the data is there and people can access it right there, they're much more easily able to build new applications on top of it. So now I'm going to talk a little bit about Landsat on AWS. So we have this public datasets program, and in the public datasets program, AWS actually hosts data at our expense. So we'll host data on S3 or in elastic block storage snapshots, and we'll make that available to anybody to do whatever they want with. And we do this to demonstrate, partially it gives us good case studies and like a really good way to demonstrate the power of AWS. But it also allows us to serve our customers much more effectively, because we know we have a lot of customers that need this kind of data. And we have a lot of different kinds of data. We have life science data. We have here, I have the 1,000 Genomes project up there, where we actually host 1,000 human genomes. It's actually more like 2,500 now, but they didn't change the name of the project. And and that was to demonstrate when we did that a few years ago. It wasn't really obvious to people that you could do genomic analysis in the cloud. And now it's plainly obvious, because you can actually store that data there. And what we demonstrated when we did that was that genomic data was very hard to get before. Acquiring that and having the infrastructure required to store that and analyze that, a lot of people didn't have access to that kind of storage. They didn't have access to the kind of computing power that they needed. But when we just put it in S3 and made it available to people, suddenly people didn't need to worry about the storage. And if they needed the computing power, they could just turn on whatever EC2 instance at whatever power they needed to do that. And then Earth science data. So NATHA Earth Exchange, it's actually very similar to Landsat, which I'm going to talk about in a little bit, but also contains a variety of data sets that explain our planet that NASA provides, and that's all readily available for people. And we put that up there to encourage Earth science research and climate research. And then I had this sort of science thing going, so life sciences, Earth science, and I just made up this term, internet science. It's more like library science, I think. It's the Common Crawl corpus that we host, and what Common Crawl is really interesting. They have a web crawler that crawls the internet, just sort of like Google or any sort of search engine indexing algorithm that goes around and crawls the internet. It produces a ton of data that's really interesting for machine learning algorithms and for natural language processing applications, and that's also readily available in S3 for anybody to analyze. So Landsat is our newest public data set. So I'll explain to you guys a little bit about what Landsat is. I have fallen in love with Landsat over the past few months as we've brought this data set on. It's extremely interesting. So there's a secret in the name of Landsat, which is that it is a satellite program that takes pictures of land. So it's called Landsat. The USGS and NASA come together to administer this program. And it's the longest running Earth observation program, or satellite Earth observation program in the world. It's really become the gold standard for how natural resource imagery is created and shared. It is what we would call big open data. And just like with the 1,000 genome story that I explained a minute ago, to work with Landsat data, you need to have the time and the capacity to download the data, store it somewhere, and then have a computer that can actually do analysis on it. And this is really difficult because Landsat data is extremely rich. So the way the satellite works, it covers the entire planet every 16 days and takes imagery. And really, I mean, what it's doing, this is at a sort of very mechanical level, it's reflecting the light, or it's measuring the light that's reflected off the Earth, okay? So it's very much sort of like what a camera does. It is a sensor that just detects light. But Landsat detects not only the visible light that we see, red, blue, and green light, but it also detects infrared light and gathers information about the aerosols in the atmosphere, as well as thermal data. And so each of these pictures, like the one that you see there, ends up being about a gigabyte of data, and which is, it's pretty big. So downloading an entire gigabyte of data takes time. And again, if you want to do any sort of analysis at scale of Landsat data, you need to have a lot of storage to be able to store gigabytes or terabytes of data, or petabytes even, of Landsat data. So not a lot of people had this, and so it ends up being time-consuming and expensive. So what we did is we created Landsat on AWS. So we've committed to hosting up to a petabyte of Landsat data. The way we're doing it now is, so the satellite's up there, it's taking pictures right now. As those images are created, we get them onto S3 as quickly as possible. Another big distinction between the way Landsat was traditionally acquired by people and the way that we provide it is that to get a picture, you'd have to download all of the bands of data. So all the visible light, all of the infrared light, the thermal data, everything like that, which again, I said is about a gigabyte. What we do instead is we make each band of each data, which is just an individual file, an individual image, we make that available as its own object on S3. And what this does is effectively creates a RESTful interface to get the data. You just need a URL, and you can get the data that you want. You can write scripts to get just the data that you want, send that to EC2, do whatever kind of analysis you want on it. And you don't need to worry about investing in hard drives or computers to be able to do that. You can only use the computing power that you need when you need it or when you want it. And so before we launched it, we showed this to a few people and said, show us what you can do with it. One of those was ESRI, and they built this awesome thing they call Unlock Earth Secrets. And down at the bottom, you can see, I don't know if you guys can see this, but the URL esri.com/Landsat on AWS. They have this map that you can interact with, and you can put in a location, you can search for your house and do whatever. And you can actually click on the left side, there are all these buttons that will show you different sort of analyses that you can do of the imagery. And it will show you what happens when you combine certain bands of data, certain kinds of visible light with infrared light to see where there are rock geological formations, where's their vegetation and things like that, where's their groundwater. And it's really fascinating. I mean, even if you're not into earth science, it's really fun to look around. I showed my parents who are in their 70s this thing and lost them for like an hour. They just kept like putting in the address where they live or where they grew up and poking around on the map. It's actually quite a bit of fun. There's another cool tool called Landsat Util, and which is a command line interface to access Landsat data and to perform sort of basic manipulations on it and an analysis of it. There's a company called Development Seed that contributes quite a bit to this. It's an open source project. And because Landsat data is available on S3 and because it's available the way that we made it available, where you can get each band at a time, they're able to double the speed of Landsat Util, which is pretty tremendous, and actually add quite a bit of features to it. There's also Mapbox, which is another local company here in San Francisco. They mashed up Landsat data with OpenStreetMap and created a real-time map, or near real-time. So if there's snow on the ground in the real world, there will be snow on the ground in their map. Give or take about 16 days because of the way Landsat works. But it's pretty tremendous. Nothing like this has ever existed before, where you can just go on the internet and see near real-time imagery anywhere on the planet. And then finally, Matlab. If any of you guys use Matlab, they built a plugin for this. And again, there's a big long URL here that I don't expect you to read and type in right now or anything like that. But if you search for Matlab AWS Landsat, you'll get to see they created a really nice video tutorial of how you can use Matlab to search for Landsat imagery and do analysis with it on your desktop just using Matlab. The video is really great. They're pretty enthusiastic about it. And then the other company that we worked with before we launched Landsat was PlanetLabs. And so before Frank, I'm going to introduce Frank. I mean, you can come up here if you want. But so we worked with Frank. Frank helped us a lot with the data ingest for Landsat and making it available in a way that was useful. And I just have to say we're very, very lucky to have worked with Frank. He's spent over 20 years of his career working to make more geospatial data more available to more people. And PlanetLabs is, if you don't know what it is, it's a really cool company. They're here in San Francisco. They make satellites. They're here in the city. They make satellites in their office. It's kind of crazy. They deploy these satellites to create more data that more people can use for humanitarian effort, and also for commercial applications, but to improve life on Earth. So Frank's going to talk a little bit about Landsat and open data in general and why it's important. Thanks.
As he mentioned, I've been in the geospatial field for about 20 years, working on various remote sensing software and also geospatial data translation, that sort of thing. So from about 1998 to 2011, I worked primarily as an open source developer, although I'm still developing on open source software now, and was involved in the launch of an organization called OSGeo, Open Source Geospatial Foundation. But while the OSGeo is about open source, we really quickly established that open source was actually not useful without open data. So I mean, it's a little useful, but it just like totally multiplies the utility of the open source to actually have open source, to have open data sets. So I mean, I was already we could say an advocate of open data for a long time before that, but it was interesting to me that it clearly became obvious in that community that open data was actually a huge part of making things happen in this geospatial world. So I really come with some of that background. I'm not a very sciencey guy, just a software developer who moves a lot of pixels around, but I've been doing it for a long time, so I have some experience with that. And I work on the data pipeline team at PlanetLabs. I won't talk too much about PlanetLabs today, but I will just mention that we do all of our image processing on Amazon. We were already very interested in the Landsat data and loading a lot of it and stuff like that. So yeah, anyways, I won't go into that detail, but for all the reasons actually that this makes a lot of sense for Landsat data, in fact, Amazon's been a great environment for us as a company as well. Okay, so open data, why? So I'll start out by saying why not? When you start talking to people to try and open up existing data sets from government and other organizations, reasons you get that are against it are it's very expensive to produce the data, and it's also hard to control. So the United States is very lucky, and I think I'll get into that a little bit later, in having a very open data policy, but in a lot of countries, national mapping agencies really try to do cost recovery around all their geospatial data sets, and I suppose this might apply to some other fields as well. So that's basically the arguments we fight against. So the reason, then you turn that around and say, well, why open data? Well, open data really drives utilization of the data. So in the Landsat in particular, there's just a huge number of different things, from agriculture to forestry to understanding the world in all sorts of different ways, that are enabled by having access to this data. The Landsat program has actually gone through a few different iterations of how they manage data, and for a while during the 1990s, they licensed it all out to a commercial organization that then charged for it. What they saw was that utilization went down, and then sometime around 98 or 2000, something like that, they actually switched it up again and made it totally public. And they noticed download rates or utilization rates going up by 10x or almost 100x. So it just made, it was like ridiculous. They were operating this super expensive satellite program. It costs on the order of $800 million to launch a new version of Landsat. We're on Landsat 8. And if you're only getting a tiny fraction of the actual utilization of that data, then that's a tragedy. So I think that the main reason I'm excited about open data, or one really important reason I think that the providers understand, is that open data drives up utilization. So certainly when you're a government organization and your taxpayers are already paying for it, that's kind of a no-brainer, hopefully. Also, it's a real enabler for innovation. So there are maybe some existing consumers of data who might use it anyways, but if you have to purchase it and you have to do all this evaluation before you can even start trying to work on an algorithm, then that's a real limiting factor. I work in the open source field. There's a lot of hobbyists, or a lot of kind of non-traditional users who have interesting ideas they love to try out, but if you actually had to go buy multi-$1,000 data sets and stuff like that, they would just never even get off the ground. So what you find is people experiment and start scaling up things that never would have happened otherwise. Landsat is one data set I'm going to talk about. I think I talk about others maybe on the next slide. No, not yet. But other data sets that are examples of this are, for instance, the American Census Bureau produces a thing called Tiger Line, which is basically a roadmap of the entire United States. They really just do it so that census takers can get to every single address. It's not the greatest roadmap data, But because it's free, it's actually super widely utilized. So people do all these geocoders, find my address, things like that. People do actual mapping. So there's a project called OpenStreetMap, which actually in the United States started from the Tiger data. And in fact, I used to work at Google, and Google Maps data, when they went from using commercial providers trying to build their own, they basically started from the Tiger line data in the US. And the point I'm trying to make there is that open data sets like that just allow an awful lot of things to happen. So here in the United States, for instance, really easily, that in other countries just never even get off the ground. So it's a real an enabler for innovation. So in the USA, so one of the things I think is fantastic about the United States is that the federal level, at least, open by default is the standard for science data, geospatial data, things like that. So that's actually quite rare in the world, and it's now become kind of a leading example for other countries. But Tiger Line I talked about, roadmap of the country. NAEP data is basically air photo data for the entire country, and the Federal Agricultural Department, the USDA, co-funds this with the states to collect it for agricultural purposes. But once it's collected, they said, well, their policy is that the data is open. So this is actually also very widely used data set for base mapping. So a lot of commercial satellite image maps actually start with NAEP data in the United States and then fill in stuff in cities or get some other data sources, but it becomes the sort of common base map. Landsat, obviously we've talked about quite a bit before. Actually, I was going to say the NAEP data is actually 2-meter imagery, so it's 2-meter pixels, so it's actually fairly high res as opposed to Landsat, which is about 30-meter resolution. Big advantage of the Landsat, obviously, is it's a long, continuous time, it's global, and it's every 16 days, whereas other data sets might be every few years, that sort of thing. And in fact, NASA and NOAA is the sort of weather part of the United States government, among other things. And the USGS actually have a lot of other more sciencey data products that contribute to climate change analysis or understanding weather and things like that, which they host and make available in various, often kind of awkward ways, but that is also really valuable data and gets used a lot. So I'm from PlanetLabs. We consume a lot of open data sets. So I tried to make a little list of it. Landsat 8 PAN is actually slightly higher resolution Landsat data. We use that and RGB imagery. I think I'm going to talk a little bit about we have several different uses of the Landsat data. So one is when we get images in space, we need to figure out where they are on the ground. We have a rough idea from where the satellite's pointing, but that's very rough, within maybe 100 kilometers. So we actually search around comparing it to Landsat data, basically, until we get a good lock. So it's the core of our sort of spatial correction algorithms. We also, the sort of color behavior, or radiometric behavior of our imagery is not always perfect. So we actually build an RGB, a regular 2-color mosaic of the Landsat data for the whole world, and then we use that as a color target. So we actually use the 3 of the RGB bands for that. So that's really been a fantastic and necessary resource for us. There's a bunch of other different open data sets that we use for various things. Agricultural data, a lot of elevation data. So these are all elevation data sets. And also roadmap data, so OpenStreetMap, and also cloud predictions. Actually, yes, so I was mentioning the weather data. So one of my recent efforts is ingesting public weather data so we can decide where we ought to turn the satellite on to avoid collecting all clouds. Anyways, my point is just that there's a lot of different, we're in no means unique in this. So just up the street from us on 9th Street is Mapbox, and they're using a lot of the same data sets to do image mapping, similar purposes. I can go a few streets over to 2nd Street, and Amigo Cloud there is building a lot of similar kind of map data sets. So that's all just within a small part. And over in the Mission, there's Stamen and lots of other companies just in this city alone that I happen to know as friends and cohorts, working with a lot of these same data sets. And then as you start expanding that over the country and the world at large, it's basically a huge community of people using these things. And I think that's fantastic. But each of them is basically has traditionally been trying to do this in isolation. They're basically setting it up in ingestion streams, so a bunch of batch jobs or whatever kind of mechanisms to pull it from the USGS or other sources, sometimes from secondary sources, sometimes only subsets of the data. There's a bunch of reasons that's complicated. Usually the way originating organizations provide the data is in possibly idiosyncratic or odd data formats. I've made my life doing data format translators, so I don't mind that as much as some people. Also, some of the services are actually quite slow and awkward to get through. So one of the challenges in this whole program was getting things from the USGS. It kind of comes out in a trickle. And So that's one issue. Incomplete mirrors. So sometimes people pull from other mirrors, or someone else has pulled it and they try to copy it from them, but they're not always a complete data set. And some of these data sets, certainly Landsat is a very dynamic data set. So something like NAPE, you only have to do it every 2 years, but some data sets are actually very dynamic, and that makes a big hassle. Obviously, storage for some of these data sets, Landsat will eventually be on the order of a petabyte, so that's a lot of storage. PlanetLabs was already storing on the order of, I guess, 75 terabytes of Landsat data before this program even got started from previous years. And storage is reasonably costly, so that adds up, and as you scale it up. And such a waste of bandwidth. One of the things I've always found really sad is the USGS's servers are slow, and here you just get more and more people hitting them, and it's quite tragic. But also just to think about moving this all around the country from one data center to another, to somebody's desktop, into offices and stuff like that's crazy. So why not share one copy? Exactly. So I felt kind of like this would have happened even if JED and Amazon had not stepped up, that between us and Mapbox and a few of the other organizations that were just in my social circle, we eventually would have come to a similar conclusion and done it for our own purposes. But this program's really been fantastic for doing it right out in the open and really doing it at full scale. Right, so why not share one copy? So one example of where this has been successful is the NAPE data. So the NAPE data is only about 3 terabytes for imagery of the country. But that's still significant to be throwing around, and the only way you could get it from the USGS traditionally was send them a disk drive, and they would send it back with the data on it. So that was a hassle, and a lot of people, if they wanted to do something quickly, they just wouldn't get around to it before their project was over. Mapbox actually did that process, and it's an important component of their image mapping solution. But they actually cooperated with Mark Korver at AWS, who made it available in an S3 bucket with requester pays. And then I was able to incorporate it into our system without actually having to do another whole ingest or store an extra copy and things like that. So that was actually fairly successful for us. And then we were able to build stuff around that. Right, so I actually built a mosaic from that without ever having to literally have a copy of that data, so that was nice. I will say there's complexity to the requester pays model that makes it not super easy to just jump in and utilize for small projects. And obviously, Landsat and AWS is another real obvious, is the other project that I really want to talk a lot about here. So in fact, there's a bunch of different parties involved in making this work. Obviously, JED led it up and provided the Amazon resources, which were very important. Folks at Mapbox had already set up an ingestion stream and gave us some of the components. I did a lot of work also on scripts and things like that to make it work, and ran it on our own EC2 instances. So compute wasn't really part of the sort of offer from Amazon. So that's no problem. We were already processing scenes like this anyway, so it's great. No problem for us to do that. Also, other partners, so ESRI actually pushed in a huge chunk of data, back catalog data that was very helpful to us as well. So we're keeping all the scenes from January 2015 forward, and we have some back catalog to give us some historical context, although it's not complete, till I guess we fill up the petabyte, and hopefully by then everybody will be so excited there will be no problem coming up with a going forward solution. So in fact, I've gone, I think I talk about that, yeah? Oh, organization of the data. Okay, so this is very important. There are some lessons compared to sort of traditional data serving mechanisms that I think are important to try and internalize when you're trying to basically make data locally available in the data center, I should say locally in the data center for immediate use. So organization of the data is really important. Traditionally, a compressed tarball of the entire scene contents would be the way that this would be distributed from USGS or other sites. That's nice for completeness, but often you only need parts of the data. And so that's very inefficient. In fact, even just to look at the metadata file associated with one of these scenes, you would actually have to download a gigabyte file and extract a 20 kilobyte file, which is just terrible. The other thing is you can actually organize data. So in this case, the images are actually organized in TIFF files, and there's a lot of different ways of organizing TIFF files that allow you to actually reach in and only use parts of the file and things like that. So part of what we did was actually organize the files in internally tiled and with overviews. And what that means is you can actually directly fetch those files and start serving maps from them or access them at reduced resolution, things like that. So I feel like whenever we're setting up these sort of programs, it's important to think about how can we organize the data so people don't have to go through a translation or an ingestion step, that they're ready to use. So in the image space, those are a couple things. The other thing that was really nice is because they weren't externally compressed, stored on S3, we can actually do sub-region gets via HTTP. So for instance, when I said they were internally tiled, you could actually just pull out the tiles from within a TIFF using HTTP GET, and I've got some libraries that make that relatively easy, so I was quite excited to see that utilization step. Okay, some of it's probably not of broad interest here, but we did provide, of course, a simple index file as a CSV file. So obvious advantages, it's easy just to pick out the parts of the data you want, whether it's just band files or even subregions of images. I mentioned the subregion GET. It certainly reduces the load on the USGS, who was having trouble serving all the people who wanted to pull it. There's various ways you can get at the data in S3, so you can just do direct HTTP fetches, or you can use some of the mount and S3 bucket as a file system, and we had carefully constructed key names so that it's sort of organized like you would think a file system is, and that makes it very easy to use on EC2. And because we don't try to really bake in a lot of services around it, it's actually very easy now to build services around it rather than having services as part of the solution. So in sort of previous projects that I've done that were sort of vaguely related, it's like a whole compute environment, and there's like a particular API to get at everything, and then it makes it very difficult to extend it or do other things. But this basically can look basically like you know, an FTP server to people who are used to working that way or whatever. So we have actually reorganized our ingestion system. So we had previously been keeping private copies of parts of the Landsat data we wanted. So I went back and sort of redid our storage system so that we could actually refer off to this bucket, and that's been quite successful. One of the things we do is we build this mosaic of the entire world. So that's about a 10 terabyte mosaic where we take all the data and digest it to get cloud-free sort of best pixels, that sort of thing. So I'd done one of those runs last summer, and I was trying to get one done this week, but due to our issues on our job system, it's not completely complete. But this is all using basically now a much deeper stack of data because we've got all the new data that's in this Landsat PDS bucket. So that's already proved quite useful for us, and we've got more data with less, you know, that we have to store ourselves. And we actually also keep up to date with this now hourly. So in the past, we did sort of ad hoc ingests of some data, but now, because this is constantly being updated, we can basically just tie into that and always have the latest and greatest, which is an advantage to us as we start trying to do much more seasonal and temporally sensitive use of the data. So you don't need to look at all this. The only thing I wanted to point out here is we actually have a way now in our storage system of pointing off to external buckets. Also, at the same time, I built in support for pointing off to any other HTTP resource or any other S3 bucket. So I feel like this concept of remote data sources that you don't copy is just a generally very valuable thing to us. And I hope it's a model that others will sort of recognize as valuable in these data processing streams. So future steps. One of the going forward, so we've got the ingestion stream working quite smoothly, and now part of it is about promoting its use, trying to find other people who are doing things similarly to sort of my social community, and getting this idea across to them that this is a resource that they can build on. And so partly that's about diverting people from pulling directly from the USGS so that it's not so overwhelmed. So there's also various integrations. So Jed's already talked about a bunch of those that are going on right now. Landsat Util for me was quite an exciting one. And getting those people interested in doing catalog interfaces over this, but where there can actually be several different approaches to this. And I'm looking forward to actually making some of our Mosaic products as public data sets, not necessarily through the program, but similarly accessible perhaps in an S3 bucket that PlanetLabs would pay for. More operators, so I just mean, this has been interesting, I think, in the sense that it was done as sort of a community collaboration. So there's a bunch of different people involved, and I want to get to the point where it doesn't just have to be me if I lose interest or get hit by a bus, that we basically got a small community sort of built around this open data set that can kind of carry on and make sure everything works smoothly. So it was now, it's almost a year ago, I guess, that I was first kind of waking up to this concept that cloud hosting of open geospatial data sets is the future. So I've been interested in open data for a long time. This concept of put it in the cloud, close to where people are going to do their processing, organized in a way that's directly useful so you don't have ingestion streams, you don't have all this reprocessing, that this is really the future. So I've been really trying to advocate on behalf of it. But there's a bunch of things to keep in mind. Public HTTP access, there's a lot of things that can happen when you do it over HTTP that are really valuable. It's really important, I think, if you want to make these things popular, that you actually preserve the original data. So I talked a lot about how we reorganized it into bands and things like that, but what I tried to make absolutely certain of was that absolutely every pixel was the original digital number. That a scientist has no reason not to trust this organization of the data just as much as the original one. So we didn't reprocess it to be visually attractive. We didn't approximate it. We didn't do lossy compression, none of those things. So this is effectively just as valuable as the original form of the archive from a science point of view. They can trust it, but it's just organized for better use. It's important that once you set one of these things up, that you treat it seriously, that you keep it up to date. So we've been, with a few minor flaws, we're trying to take very seriously that it's kept up to date within a few hours of whatever the USGS would have to offer, so people don't feel a need to give up on it and go to other sources. So there have been other mirrors that were incomplete for various reasons, or if something got broken, it wasn't considered a major, an important thing, and so they didn't necessarily go back and fix it quickly, and that really kind of undermines the effort. So I think that's important. Also, it would be very valuable anyways if it's complete. So we're doing complete going forward from this January, and certainly it's even more valuable when it's complete all the way through its history. And one could look back at the whole history of Landsat. There's like, in previous projects we've done like 20-year Landsat mosaics or composites or video streams of the whole world at 30-meter resolution, from the whole Landsat archive. So what I would love to see as a future step, probably not funded directly by Amazon, but perhaps by the data originators or a community of interest, is to go back to Landsat 7, Landsat 5. These are immensely valuable long-term archives of information that you can utilize and try and get all in there. So I think data completeness is a really important thing. I would also say there's a lot of other geospatial data sets that are of great interest. So I know that Stamen here in town are doing a big project around various elevation data set sources. And I think that they're committed to hosting that publicly in S3 or somehow at Amazon. And we consume a lot of those data sets too, so that'll be a big help to us. We actually want to publish some of our own data sets. So probably the Landsat mosaics that I build, but also ultimately we'll be serving a lot of our own satellite data, and parts of that will be treated as open data, whether for particular regions or older data and things like that. And we want to make sure that we take some of these lessons we've learned here and make that apply there. All right.
Break. So how are we doing on time? Okay, so we have a few minutes left. So you remember this thing? So I want to talk about, building on what Frank said and explaining how when the data is in the cloud and when data is available on S3, it really acts like this platform. And so the story that we just told, right, was, there's Landsat, that's the satellite. We did some processing in EC2. We put it in S3. And it allowed development seed, Matlab, PlanetLabs, Mapbox, and ESRI to build applications extremely quickly. I mean, on the order of like weeks. And the upshot of that is going to be an increase in volume of climate research being done, in the development of agricultural applications, the development of mining applications, better land use planning. Like in the state of California, I mean, this data can be used to help, with the drought. Help farmers understand where to irrigate, when to irrigate, or what kind of crops to plant and things like that. Not to mention educational tools. It will allow students to get involved with earth science much more quickly. One anecdote that I love about this is we launched this thing. It was March 19th. It was a Thursday. That weekend, a mining industry hackathon in Australia was using the data. A team there built some sort of proof of concept of using machine learning on Landsat data to find titanium mines, which is like the craziest thing I've ever heard. So I love it. We're really happy that this has sort of demonstrated the story. And I'm gonna go out on a limb and guess that not everybody here is super into geospatial data and satellite imagery. And so I really want to make the point here that this story applies to any kind of data. Whether you're working with permit data, crime data, anything if it's at a municipal level or state level, health data. And in the case of Landsat, Landsat is a sensor. So any kind of sensor data that's producing data, this same sort of model can play out. It just depends on, a lot of the things like what Frank said in his last slide. I'm going to go back to that. Is as long as the data is organized, that it's documented, that people can rely on it, and that it's available, in the cloud, close to computing resources, it's going to enable them to do a lot of things with it and innovate in tremendous ways. Oftentimes when I speak to our government customers who are interested in opening data and they don't know what to do or how to approach it, I give sort of 3 key pieces of advice. I say, make sure the data is good in the first place. Make sure it's accurate. That's on you. You want to be a reliable source of accurate information. Document it, and then make sure it's there tomorrow. And if you can give people that assurance that they understand what they're looking at and that it's good and that they can count on it being there tomorrow, they'll build products on it. They'll start building processes around it and building tools on it. And then, I'll just take a couple minutes to talk about what you can expect from us, and then I'll leave a little time for questions, and then I'll stick around after in case people want to talk as well. So what's next for AWS? We want more open data, right? So we do have our public data sets program. It's limited in terms of the kinds of data sets that we can host. In the case of Landsat, we chose it because we knew that it was extremely valuable to a lot of our customers, and that there are tens of thousands of people who rely on Landsat data for their work. For the public data sets program, we tend to look at data sets that are very broadly applicable and useful in a lot of different sectors. But we're curious to hear from you, like on what kind of data you rely on for your job. So if you have opinions on that, I'm jed@amazon.com, or you can email us at opendata@amazon.com. But also, what Frank said, we want people to understand the value of hosting data on S3. So if you produce data and you want people to use it, we invite you to consider S3 as a place to host it and share it with people. And again, if it's sensitive data, you can also host it in S3 and have every assurance that, based on your architecture, that the data will be secure and would only be available to the people that you want to share it with. Generally, I talk about open data, so I'm talking about sharing data, broadly and openly with the world. But you can also host data in S3 that you only share with certain stakeholders that you choose. It's a very, very flexible product in that way. But generally, we do want people to understand that S3 is a great place to share data. And if you are interested in, because of your mission or anything like that, the mission of your organization to drive utilization of the data, it is a fantastic solution. We also want to add more services and features to our products. This final bullet point, I don't know if you know this, but this is true. About 90 to 95% of our roadmap comes from customer requests. So we launched a bunch of new features. Today we announced new features and services of AWS. We get those ideas from you. So again, email us at opendata@amazon.com if you have ideas of how our products can be improved or how our services can be improved, so that you'd be willing to open up more data on AWS. And then another thing that we do is we're creating more resources so for people to get started and understand how to use our products. And so an example of one of these things is what we call the AWS JavaScript S3 Explorer. It's a pretty catchy name. It's a JavaScript application, so it's just a little JavaScript application that lives in an HTML file. And you can get it on GitHub. It's on our AWS Labs account, so if you go to github.com/AWS Labs. You can get it, you can fork it, and do whatever you want with it. It's a very simple application that uses the AWS JavaScript SDK, and you just put it in an S3 bucket, and you get a URL to load up that page, and it will display the contents of the bucket. So if you have files that you want to share with somebody, if these are data files or really kind of any kind of object, and you're comfortable doing this, you can put that HTML file in the bucket and then send people the URL to that, and they'll be able to see the list of the files and download them and navigate through the bucket. It's a really cool little app, and we want to build more stuff like that. So that is what's next. It's all fits on one slide. So again, I thank you guys for coming and spending the end of the day with us. We do have we've got like 10 minutes. So if anybody has any questions, feel free to ask, and we'll be hanging out here in front as well. So if anybody wants to ask any questions publicly, that's fine. Yes, sir.
For example, you go Wikipedia, I think, the Wikipedia and dump. I think you have that out as open data.
Yeah, in our public data sets catalog, yeah.
And that's an RDF-based format.
Yes.
Do you provide like a Sparkle interface, or do you repurpose that into some kind of other format?
We don't. So actually, to go back to sort of Frank's point about making the data available in some sort of like logical, accessible way, we really toe the line and don't cross that line into writing software for this sort of thing. Yeah. Oh, sorry. Oh, thank you. Yeah. Oh, I'm sorry. I should have repeated the question. Sorry.
It's on?
Yeah.
Okay, my question is stemming from his. So what if there's like an open data set from another source that doesn't host their data on AWS? How can it be reconfigured to be integrated into what you've built on AWS?
Okay, so if it's available via an API and it's a RESTful API, so you can just access the data via like a URL, you can use that too. It doesn't really matter. So you can spin up an EC2 server and have an application in there that accesses the data over the internet just as easily. The advantage of having that data on AWS in the first place is just that it'll be a lot faster to access the data.
This might apply to the work that the other gentleman's doing too. Is there an effort to produce like a sort of a GIS ontology or an open source taxonomy that can sort of be a Uber layer of metadata over all this open data, so people can kind of drill in and find? It's great to look at what's on the file system, but it's
Right.
better to have something at a meta catalog level.
Right. So I mean, I guess I would think back to the chart of of data enrichment on that x-axis. It's constantly happening. And the Earth is also constantly changing. So there are many efforts to do that sort of thing. Well, one of the nice things about Landsat, it's been around for so long that they have it's called the path and row system. There's like a name for the path and row, like global reference thing. But it's which is sort of like a latitude and longitude type thing that really sort of makes sense out of how the Landsat data is arranged. And then there's also like projects like OpenStreetMap that try to do the same sort of thing. But anyhow, I mean, those efforts do exist, and I think that probably the best place to look into that sort of stuff is, what is it, OSGeo? Yeah? I mean, I'm just gonna, I'm gonna rep Frank and say that, yeah, OSGeo is probably a good place to look into that.
Can I ask
Yeah.
the next question? Okay. Do you guys have any open data sets on brain neuroscience or cognitive science?
We should talk. Yeah,
Okay.
we don't have anything available right now, but that's to my point. If you're interested in this sort of thing, I'm definitely curious to hear what you're thinking about.
Okay, I'll talk
Yeah.
to you afterwards.
Thank you. Anything else? We got 5 minutes left, so you can get out early if you want. Thank you again. I really appreciate you coming. Thanks.